All right, today we're diving deep into one of Python's most fundamental concepts, how it actually handles the data you give it. You know, understanding the difference between what's mutable and what's immutable is an absolute game changer for writing clean, efficient, and bug-free code.
So let's start with a simple question. You've probably typed something like x equals 100 a million times. It seems so basic. But what is Python really doing under the hood? You might have a simple picture in your head, but the reality is a little different. And honestly, it's the key to understanding everything else we're going to talk about.
Okay, first up, variables. And here's the big idea. We need to start thinking of them as labels, not boxes.
This is a really important mental shift to make. A lot of us, when we start out, we picture a variable as a little box that you stuff a value into. But in Python, it's so much more helpful to think of a variable as a sticky note, a label that you attach to an object. The variable itself doesn't hold the data, it just points to where that data lives.
So what is a Python variable, really? At its core, it's just a name, a tag. It holds a reference. Think of it like a signpost or a shortcut that points to the actual object, which is sitting somewhere in your computer's memory. This separation between the name and the object itself, that's everything.
Well, let's make this super concrete. We type x equals 100. First, Python creates an integer object that holds the value 100. That object gets its own unique ID, which is basically its address in memory. Then, the variable x is created, and it's just a label that gets pointed at that object. So x isn't the number 100, it's just the name we're currently using for it.
So then, what happens when we write x equals 200? Are we opening up a box and swapping out the number? No way. Instead, Python creates a brand new integer object, 200, with its own different ID. Then it just peels the x label off the old 100 object and sticks it onto this new 200 object. The original 100 is now just sitting there unlabeled by x.
Okay, section 2. Let's talk about immutable types, the unchangeables.
This is pretty straightforward. Once an immutable object is created, its state, its data, is completely locked in. You cannot alter it after the fact. It's set in stone.
And you've probably run into this. Take a string, for instance. You make a string called hello, and then you think, oh, I'll just capitalize that first letter. You try to assign h to the first position, and bam! Python immediately throws a type error. The message couldn't be clearer. String objects do not support this. You literally cannot change a piece of it.
So, what are these unchangeable types? Well, it's a lot of the basics you use every day. All the numeric types, integers, floats, complex numbers, they're all immutable. Same goes for strings, bytes, and booleans. And when we talk about collections, the big ones are tuples and frozen sets. Once you make one of these, it's final.
All right, on to section 3, mutable types. I like to think of these as the chameleons of the Python world. So, if immutable objects are set in stone, mutable ones are like clay. The key phrase here is in-place modification. You can change their contents, add things, remove things, tweak things, all while the object itself stays in the exact same spot in memory. Its identity never changes. Let's see this in action, because it's pretty cool. First, we create a simple list with 1, 2, and 3. We check its unique ID, and you can see it's this big number here, which is its home in memory. Got it? Okay. And now for the aha moment. We're going to change that list using the append method to add the number 4. Now, the list's content has definitely changed, right? It's 1, 2, 3, 4. But look at its identity. It's exactly the same as it was before. We didn't create a new list. We just modified the original one right where it was. We mutated it in place.
And which types are these chameleons? The ones you use all the time? Lists, dictionaries, and sets. And there's also byte array, which is just a mutable version of bytes. These are your go-to containers whenever you know the data inside them needs to grow, shrink, or just change over time.
So how do you pick the right one? That brings us to section 4, choosing your container. This is where the rubber really meets the road. A list is mutable. You can change it, add to it, whatever. It's perfect for a dynamic collection, like a shopping list or items in a cart. But a tuple, on the other hand, is immutable. Once you create it, it's locked.
This makes it perfect for a fixed record of data, like GPS coordinates or a specific color's RGB value. You wouldn't want those to change by accident, right? So choosing the right one tells other programmers and your future self what your intentions are.
All right, last section. Number 5. Why this all matters. And this is the real payoff. Seriously, getting this concept helps you sidestep some of the most infuriating bugs in Python. Has this ever happened? You pass a list into a function, and the function messes it up without you realizing it. Or, oh, this is a classic. You use a list as a default argument, and the function starts behaving weirdly, remembering things from previous times you called it. Yep, those are all classic symptoms of not paying attention to mutability.
So, I'll leave you with this question. Now that you get this whole labels not boxes thing, and the difference between objects that can change and objects that can't, think back. Which mysterious bug from your own past code suddenly makes a whole lot more sense?